We're going to continue looking at radical equations, but with respect to functions and when they are and are not true. In this practice set, we're asked to find if f of x equals radical x plus radical x minus 9, find any x for which f of x equals 1. So we will replace the f of x this will give me 1 equals root x plus root x minus 9. Now I need to solve for x. So I'm going to isolate one of my radicals, and it doesn't matter which one. So I'm going to leave the root x minus 9 on one side and subtract the root x. Now I'm going to square both sides to undo the radical. On the left, I will get 1 minus 2 root x plus x equals x minus 9. I still have a radical on the left, and so I am going to have to square this equation one more time. But before I do that, I have to isolate the radical term. So I'm going to subtract 1 from both sides and subtract x from both sides. Now I have negative 2 root x equals negative 10. And now I'm going to square both sides again. I get negative 2 squared, which is 4, root x squared, which is just x, equals negative 10 squared, which is just 100. So x is equal to 25. Now, using that value, I'm going to check my solution by replacing it back into my original equation that I made. 1 equals root 25 plus root 25 minus 9. I need to show that the square root of 25, which is just 5, plus the square root of 25 minus 9 is 16. So 1 should equal 5 plus 4. So 1 equals 9 does not make sense. Now, you might be thinking, well, that doesn't make any sense. There should be at least one answer. But, in fact, there are no solutions to this statement or this request. And in fact, if you graph this, you get a graph that looks something like this. And your value of y equals 1, and it's down here. And notice that they never intersect. So there's no statement for which this is true. Or there is no value of x for which f of x equals 1. In practice set 3, we need to equate the functions. So we're given f of t equals 7 plus root 2t minus 5, and g of t, which is equal to 3 times the quantity t plus 1 raised to the 1/2. Well, remember, something raised to the 1/2 is just a radical, a square root. And we need to find any t for which f of t equals g of t. Well, that means we're going to equate the functions or set them equal to each other. 7 plus the square root of 2t minus 5 is equal to 3 times the square root of t plus 1. And we need to find any t for which they are equal. Notice that we already have one radical isolated. So we will go ahead and square both sides. This will give me 49 on the left plus 14 root 2t minus 5 plus 2t minus 5. And on the right, we will get 9 times t plus 1. Combine any like terms that you can. And then isolate the radical. All right, I've isolated the radical once again, and I have 14 times the square root of 2t minus 5. You might be asking yourself why I'm not dividing over the 14, and the main reason is it is going to turn the right side of my equal sign into a fraction, and I don't want to deal with a fraction. So it's easier just to square the 14 with the radical it's multiplied to instead of bringing it over. 14 squared is equal to 196. And I'm just going to rewrite this on the other row here in a second. So let's just rewrite it up here. We have 196 times 2t minus 5 equals, and then we need to FOIL the 7t minus 35 squared. (49t squared) minus, now this 7 times 35, that's 245, and it's going to be negative, and there are going to be 2 of those. So 490 minus 490t plus 35 squared equals 1,225. Distributing the 196 through, I get 392t minus 5 times 196, which is equal to a 990, and that's negative because of the negative 5. Now we're going to add 990 to both sides, and we're going to subtract 392t. On the left I have 0, and now I have a quadratic. So the middle term is negative 882t, and the last term is positive 2215. Now go ahead and pause the video and use the quadratic formula to find the solutions. Without going into too much detail, the two solutions that you will get from this quadratic equation is t equals 3.017 and t equals 14.983. Now, you remember, since we've squared both of these, the sides of these equations, we're going to have to check the solutions. And I'm going to let you do that on your own, but I do want to point out that one of the solutions is incorrect. Go ahead and pause the video and give it a try, and then you can find out the answer. Welcome back. So if you did the substitutions, you would know that t equals 3.017 is not a solution, and there is a solution at t equals 14.983.